I will give you some problems based on Gauss law. The first one. Figure shows 3-point charges plus 2q minus q and plus 3q, plus 2q comma q and minus 2q, sorry, minus q and plus 2q minus q and plus 3q. Two charges plus 2q and minus q are enclosed within a surface S. Minus q are enclosed within a surface S. What is the electric flux? What is the electric flux due to this configuration through the surface S? Through the surface S. Given figure, so I'll give you a figure. We have plus 2q plus q, and this is a surface S, and plus 3q is outside. What is the electric flux due to this configuration through the surface S? We can apply Gauss law to find out this. Apply Gauss law and find out. According to Gauss law, electric flux through the closed surface is given by, according to Gauss law, electric flux through any closed surface S as 5 is equal to q divided by epsilon naught, where q is total charge enclosed in the surface. Total charge enclosed in the surface. Now see the diagram. Plus 2q and plus q are the total charge. Sorry, this is not plus q, this is minus q. I'm sorry for this. So this is not plus q in the question, it is mentioned minus q, so this has to be minus q. I'm really sorry for that. So plus 2q and minus q. The total charge enclosed is 5 is equal to plus 2q minus q divided by epsilon naught, which is equal to q by epsilon naught. So the flux through the surface is q by epsilon naught. So make a note, plus 3q is outside the surface, and therefore we are not considering it when we apply Gauss theorem. Note, plus 3q is outside the surface. So we are not considering it when we apply Gauss law. While applying Gauss law, remember we have to consider only the charges which are inside the closed surface. We'll take another one. A charge Q is placed at the center of a cube. Of side L. What is the electric flux? Passing through each face of the cube. First, here charge Q is placed inside a cube. Side of the cube is L. So what is the electric flux passing through each face of the cube? First you find out the total flux linked with the cube, and we know there are 6 faces for a cube. Because here the charge is placed at the center, the electric flux is symmetrically distributed through all the 6 faces. Here also we can apply same Gauss law. So by Gauss theorem, total flux through a closed surface as phi is equal to Q by epsilon naught. So we can say, because Q is at the center, total flux through the cube phi is equal to Q by epsilon naught. Now the charge is at the center, therefore electric flux is distributed symmetrically in all directions. So given charge is present at the center, therefore flux is distributed electric flux is distributed symmetrically in all directions. And because we know cube has 6 faces, cube has 6 faces, so flux link with each face. Total flux divided by number of faces. Five by 6. and 5 is q by epsilon naught, so it is q by 6 epsilon naught. So this is the flux, electric flux linked with each phase of the cube. And note that if charge q is not at the center, the flux would not have equally divided through each phase. Because the charge is at the center, then only we can apply this total flux divided by number of phases. An important note, if charge q is not at the center, then electric flux will not equally divide through each phase.